Hello and welcome back to Chemistry It Is All That Matters, and today we're going to look at how to determine the empirical formula, and we're going to first begin by defining empirical formula and molecular formula. So let's move on and take a look at what these things are when we're discussing the empirical formula of a compound and the molecular compound of a molecule. So the formulas for compounds can be expressed as an empirical formula and as a molecular, which is also known as the true formula. So the molecular formula is the actual formula we use. So C2H2 would be for acetylene, but the empirical formula is the reduced ratio of that molecular formula. So C2H2, its empirical formula would be CH, 1C to 1H. Likewise, C6H6, which is benzene, would be CH as well because it's a 1-to-1 ratio of carbon to hydrogen. Carbon dioxide, CO2, is molecular, but it is also the empirical because it is already in the lowest form ratio. And then if we looked at the sugar ribose, which is C5H10O5, we have an empirical formula of CH2O, which is 1 carbon to every 2 hydrogen to every 1 oxygen. And remember, ribose is that sugar found on RNA from your study of genetics in biology. So when we are looking at the empirical formula, we are representing the simplest whole number ratio of the atoms in the compound, where the molecular formula is the true or actual ratio of the atoms in the compound. So molecular formula can have the true number, the actual number of atoms, but the empirical formula must take those atom numbers and reduce them to lowest terms. So let's check for basic understanding before we move on. And if we have, what is the empirical formula for C4H8? Which answer would you choose? C2H4, CH2, or CH? Well, in this case, we would be looking at CH2 because we are going to reduce the 4 and 8 by dividing by 4, giving us a simplified empirical formula of CH2. So for question B, what is the empirical formula for C8H14? So is it C4H7, C6H12, or C8H14? We are going to choose C4H7 because we're going to again reduce the 8 and the 14 by dividing by 2, giving us a ratio of 4 to 7. So what is the molecular formula for CH2O? Which one of these could be a molecular formula if the empirical formula is CH2O? So is it CH2O, C2H4O2, or C3H6O3? So what we're looking for is a ratio of 1 to 2 to 1. And the answer is actually all of them. All of them have that given ratio of 1 to 2 to 1. 1 carbon for every 2 hydrogen and every 1 oxygen. So if the molecular formula has 4 atoms of nitrogen, what is the molecular formula if Sn is the empirical formula? And our answer is 3, because if the ratio is 1 to 1, and we know we have 4 atoms of nitrogen in the molecular formula, we know that the sulfur also has to have 4 to keep that 1 to 1 ratio. So Sn, S4, N4, number 3, is the molecular formula for that result. So let's look at the process of how do we determine the empirical formula, and we're going to do this from the basis of having the percent composition of the molecule. So in this molecule we have 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. Well, the first thing we're going to do is we're going to convert the percents to grams. So we're simply going to drop the percentage and we're going to change that to grams, and we're going to work from this gram value. Now the next thing we're going to do is we're going to convert the grams to moles by multiplying by the conversion factor of 1 mole over the AMU, and that will give us a mole value of 2.02 moles of chlorine. It will give us a value of 2.02 moles of carbon, and we will get a 4.02 moles of hydrogen. So once again, to convert grams to moles, we multiply by the conversion factor of 1 mole over the AMU for each of those substances. Once we have the mole value, the next thing we are going to do is we are going to find the ratio between those atoms by dividing each mole value by the smallest mole value. Now in this case, both of the mole values for carbon and chlorine are the same, so we will just use the mole value for chlorine, and when we divide that, we get a value of 1 atom of chlorine for every 1 atom of carbon for every 2 atoms of hydrogen, and that will give us our final empirical formula, which is CH2Cl, 1 carbon, 2 hydrogens, 1 chlorine. So let's look at another example of that process. So here we have aspirin, which is 60% carbon, 4.5% hydrogen, and 35.5% oxygen, and we're going to calculate the empirical formula. So again, the first thing we do is we convert the percents to grams. So that 60% carbon becomes 60 grams of carbon, the 4.5% hydrogen becomes 4.5 grams of hydrogen, and the 35.5% oxygen becomes 35.5 grams of oxygen. Next, we're going to take those gram values and multiply them by the given conversion factors to convert grams to moles, and in this case we're going to get 4.99 moles of carbon, 4.45 moles of hydrogen, and 2.2 moles of oxygen. Now we're going to divide the smallest value, which is the oxygen, into each of the values, and that will give us this setup here. And when we do 4.99 divided by 2.22, we get a value of 2.25 atoms of carbon, 2 atoms of hydrogen, and 1 atom of oxygen. Well, the problem here is we can't have a quarter atom. So how are we going to fix this? Well, using these decimal breakdowns or fractional breakdowns, when we have a 0.5, we're going to multiply by 2 to get a whole. 0.33 we multiply by 3 to get a whole value. 0.25 we multiply by 4 to get a whole value. 0.667 we multiply by 3, which will give us actually 2 whole values. And 0.75 we're going to multiply by 4 to get actually 3 values. All the other values will simply round up. So anything 0.1 or 0.2 round down, 0.8 or 0.9 round up, everything else in between is covered here. So what we're looking at is we are going to give ourselves whole atoms by multiplying by a factor that changes the decimal to a whole number value. So in the case of 2.25 atoms of carbon, we need to multiply by 4. So that's going to give us 9 atoms of carbon. It will give us 8 atoms of hydrogen, and it will give us 4 atoms of oxygen. And now we have our ratio of atoms, which gives us the final empirical formula of C9H8O4. So this is how we change percent composition to the empirical formula, and using that process we can figure out the empirical formula of any of the molecules that we will be dealing with. So keep working on your chemistry.